the biggest thing I would say is not exactly that they are tougher or less tender, let's say, but we have greater variability.
Hmm.
So the thing is, we will have everything, and this gives us researchers the opportunity to track let the best ones, let's say, the animals that are prone to produce um, tender beef.
Welcome to the Beef Podcast. I'm Travis Molyneux, and today I'm glad to have Dr. Patricia Ramos here from Brazil. Patricia, tell me about your background of you're a meat scientist trained. You did some training here in the United States at University of Florida, but you're back down in Brazil. And you look mostly with tenderness and meat science of Bos indicus cows. So kind of tell me what you do and what your interests are.
Okay, thank you for having me. It's a pleasure to be here. Yes, so about my background, I am an animal scientist. I graduated here in Brazil at University of São Paulo in the same campus where I'm working now. So I'm back home
Mm-hmm.
after having a time, yes, at University of Florida. I worked with Dr. Tracy Scheffler, and we investigated muscle metabolism postmortem. Um, so my great interest is to try to understand mitochondrial contribution for this early energy um, upload, let's say, during the start of meat, the muscle to convert to meat. So my PhD is also from University of São Paulo, and during this time I studied under Dr. Delgado. Um, he was my advisor. Dr. Eduardo Delgado have his PhD from University of Arizona, so he studied a lot of calpastatin contribution for meat tenderization. They used at the time the calipage lamps. So with this strong background with calpastatin and also Tracy's background with mitochondrial contribution to meat quality, I'm now interested and I'm researching it now at University of São Paulo, the relationship with between these two in our model. So that is Bos Taurus indicus cattle, the Nelore cattle here in Brazil.
So we've always thought, and there's been a lot of research historically, is that Bos indicus cattle are less tender than Bos taurus cattle. And so in your research and moving forward, have we found that may not always be the case, and how can we make those Bos indicus carcasses or cattle to be a little more tender?
Yes, so the biggest thing I would say is not exactly that they are tougher or less tender, let's say, but we have greater variability.
Hmm.
So the thing is, we will have everything, and this gives us researchers the opportunity to track let the best ones, let's say, the animals that are prone to produce um, tender beef, right? So um, we do have, in my opinion, this great variability, and our research also shows that these animals, since they can handle better the environment, the harsh environment, because they were selected under these tropical conditions, this resilience can be translated to the early postmortem metabolism. And they also have greater calpastatin activity. So there is a couple of, let's say, genes that we can track
Mhm.
and select animals that are prone to produce a tender beef within this cattle. And also, we can handle them in a way that we don't stress them too much, because their stress response can increase calpastatin activity and also uh, make this tenderization process a little bit difficult.
So is the calpastatin response more or due to their excitability or the response to stress? Is that different response if the same amount of stress was put into a Bos Taurus cow? Would the response be very different in that Bos Indicus cow, and how is calpastatin changes between those?
When we compare Bos indicus cattle with the Bos taurus cattle, this was in terms of calpastatin expression,
Hmm.
so content and activity. The Bos indicus cattle have more. So that's that is the thing for their stress response being harder or increasing calpastatin activity. So you have more and you have a greater response in terms of
Hmm.
increasing something that we don't want, right? Because
Right.
calpastatin will inhibit the calpain activity and all the tenderization process. So I I would say that if they are facing this same stress under tropical conditions, I would also expect for about Bostaros to produce less tender beef, because they don't thrive under these conditions as well. So we have another other factors playing their part in decreasing the quality, let's say.
So that's highly related to um, their the heritability of their ability to handle those stressful environments that they've been selected for is highly heritable to the basically tenderness go hand in hand, right? Is so selected for this animal for so long that's resilient in that system, but also selected for something that drove that system to be a little more or less tender then.
Exactly. And also, maybe it's not the case in the United States, but here we have also this pressure to animals, Bos indicus cattle, that perform better in
Hmm.
feedlot, for example. And sometimes you're selecting this particular characteristic is not the same as select animals that will produce greater quality.
Hmm.
So the pressure to produce beef in great amount uh, will be like going in the opposite direction to have greater quality. So our focus now with research is to improve or to find those animals that produce greater quality and select them and bring them to our feedlots and handle them
Hmm.
better, so we can increase the amount of high quality beef that we are producing.
Made me think about, there's a lot of F1 crosses of Angus and Allure crosses in Brazil. And I've always heard that those crosses are very excitable. And are you seeing a change in meat quality in crosses that is for the better, or are you seeing some of the same lingering effects of tenderness, etc.?
So to decrease the contribution or the calpastatin problem, let's say, in the beef, um, we need more than just the first cross with Nelore and Angus. We need to decrease the amount of contribution uh, from the indica side on that offspring. So The excitability added with greater calpastatin is indeed a problem for tenderization.
So, from your research that y'all doing down there, are y'all finding what some of these maybe genes or managements that can decrease the the um, the number of animals that maybe have more activity, calpastatin activity, or just increase or decrease in tenderness?
Yeah, we do have like new data about that with the combination of, let's say, the favor calpastatin gene with a calm temperament. So an animal that it's already able to handle the environment and um, our people. So in our environment here, and go to the slaughterhouse without um, ex- being excitable and etc. So yeah, we do have this, and as I said before, like this great variability. It's giving us the opportunity to select these animals. Um, but it's too early to say that this can be applied commercially,
Hmm.
uh, because in our university, the herd here in our university, and my research is mainly done here with our herd, these animals were selected to be less excitable than the commercial
Right,
animals.
right.
So it's kind of, I hope to apply our research in a commercial um, feedlot, in a commercial slaughterhouse, so we can track this and have great number. So I know how this gene is occurring in our commercial producers, and so I will be able to give more like feedback on this particular issue.
Yeah, it seems like having a docility EPD that producers used as some of their selection tool could help really, drive some of that away from the excitability and then start selecting for animals from a genetic base that are a little more docile outside of just calling cows that are a little more higher temperament, have high headed or whatever you want to call it, and will help kind of quickly or quicker move that bubble away from having you know these a lot of these excitable cows in the herds.
Yes, yes. The thing here is that our cattle, it's mostly pasture cattle, so the cows need to be a little bit excitable so they can protect their offspring.
Right.
So that's the main thing that makes like the producers to select.
Yeah, it's always a catch 22, right? And back to your comment of it's of we need to go more than just F1s, but are you going to lose some of that ability, adaptability for resiliency in your systems by breeding, um, just more crosses down than just F1s. And so that's the tough part is right is you can get too far away from what you need by chasing something of tenderness, and your cow herds now do not are not resilient enough in your system, correct?
Yes, but we also have like opportunities to improve our processing, right? So there's always like applying electrical stimulation and
Mm,
handling better. We have evolved, let's say, in training our professionals to handle animals better here. So we can apply some of this research to our selection process. But it's still, if the pressure is to produce more and more in quantity, we will not be able to add this since we are always looking for a higher quality. So there's a couple of things that we need to track, but I believe our beef it's For us, researcher is like a great model because this variability give us a lot of opportunities to improve. And I
Hmm.
saw this as well when I stayed at University of Florida. Although our animals are different because the Brahman, it's uh, this selection, the genetic pressure to select better animals, this is in their past, right? We are
Right.
uh, walking in this the same way. It looks like we are trying to find the same, follow the same path, but the Brahman there, they also have great variability, and also they have the same resistant pH decline that will uh, delay the tenderization process, the protease activation, and everything related. So, using this indicus model, we can definitely find ways to improve the beef quality, adding animals that are adapted to our climate. And climate change is happening. So I believe this is a concern for all, for everyone, for all the producers, all the researchers, and we all.
So you touched on something that that's out of my wheelhouse, and so I'm a beef cattle nutritionist and not a meat scientist, and so you touched on pH decline and how that is associated with tenderness, and there's challenges, I guess, with uh, Bassa indicus cows and pH decline. Can you go into more detail what that means and why is that an issue with Bassa indicus cows?
Yes. So when I was talking about like this resilience, so this resilience of these animals in the pasture, in the feedlot, this can be translated to this initial time, this early time postmortem. So their mitochondria can still produce, or they can produce ATP longer during this early time. And with that, if we have a greater amount of ATP, we'll keep everything, the process, the enzymes, and everything, the system going. And with that, the pH decline will take longer to decline. So this is the main um, thing, and this will delay the rigor mortis onset. This will delay uh, calcium release to the sarcoplasm, and with that, everything will be postponed. And since this is happening early post-mortem, we need later, because everything is going to slow down, right? So everything
Hmm.
is happening, the tenderization is happening, but we are losing the window, the best window to tenderization to start. So we need more time later. Uh, we need to keep this meat aging longer to have tender beef.
Yep, that was my next question is how does that influence dry aging process and is that a different length of time needed?
Yes. So, for example, with Brahman in Florida, 14 days is enough to have tender beef. In Brazil, we see like something around 21, 24 days. So, which means in average, right?
Yeah.
Of course, we have animals tender at after 7 days, but in our average, we need more time. This means we need uh, cold. We need to keep it our beef inside cold room longer, and this is a problem for the industry.
Is there a difference between wet aging and dry aging for that or are they pretty much the same?
I'm not sure if I
Okay.
can answer that because I never worked with dry aging. Although I understand the process, I believe we will not have anything like differently in terms of
Hmm.
tenderization process. If it takes longer, for wet aging, it will take longer for dry aging as well. Yeah.
Well, you've been briefly talking about and bringing up mitochondria. And I know there's a lot of research going that way of looking at some mitochondrial efficiencies for end product, etc. So, what are y'all doing in terms of mitochondria and how and your research towards that and meat quality and tenderness?
Yeah, so there's a lot of research like with color, and this is not actually my focus right now. I'm trying to focus more in this standardization process and how the mitochondrial enzymes can be upregulated with this um, excitability, this temperament issue from this animal. So we know that there's a couple of indications of for the calpastatin side, and now I'm trying to relate this with specifically mitochondrial complexes. So if there is one particular complex that is upregulated in terms of activity during this early postmortem period, and how this will decrease or will impact the protease activation. So we are trying to bring these two together. But I still I'm at early stage of this research, so I will have to get back on that question later.
Yeah, no, that's great. So, is there? I guess there's a difference in mitochondrial function during that early onset between different biologically types or breed types of animals.
Yes, there is. We saw some differences working with Angus and with Brahman, and this is a really interesting type of type of thing that happens with researchers, right? Because we thought at early, well, we have this cattle that can handle better the temperature challenge, and we have these animals that cannot, let's say. And so we thought in a set for research that we would pick this mitochondrial from actually, we kept it in the fiber, so we permeabilized the fiber. This is like putting holes in the membrane, but keeping the structure, the organelles in their place. So we just replaced the medium and we put them in an oxygraph and we challenged. So the Angus mitochondrial challenge, and we challenged the Brahman mitochondria. And we initially thought, well, with the increase in temperature, the Brahman mitochondria will thrive and the Angus will not. And actually, what we saw was the Angus mitochondria kept its functionality the same under both
Hmm.
temperatures, and the Brahman decreased the mitochondrial activity when we challenge with the higher temperature.
Hmm.
So they do have a mechanism to, let's say, reduce activity so they will not produce heat, so they can adapt to the warmer um,
Hmm.
weather. So this was really interesting. This was published with the University of Florida team.
So, how does that relate back to knowing, that they can decrease their mitochondrial function with higher heat? How does that relate back to the meat quality aspect?
Let's suppose we have this disability in, and we are loading our cattle in a day that's really warm and really
Hmm.
challenging. With that, they will probably be able to handle everything, the truck loading, unloading,
Hmm.
the everything related with the slaughter process that's really challenge. Uh, and they will be able to handle as the other cattle, the Angus, the cattle that are not adapt, they cannot handle. So this will translate in terms of beef quality the same way, I would say, like, but they will probably not produce dark cutting in the
Mm,
same amount of the other breeds.
right.
So I would say it's more like something in this end. But of course, if they have problems with calpastatin and everything, they will still have the same problem.
It's time for our famous three.
Is stress affecting your bottom line? Even routine handling, inclement weather, weaning, and dietary changes can significantly lower the rumen pH, causing cortisol levels to spike. Cortisol not only compromises the immune system, but also suppresses normal appetite and feed consumption. The solution? Cattle Active. Increase production and reduce the impacts of stress on your cattle for cents a day. Cattle Active restores the balance naturally. Want to learn more how a feeding program including Cattle Active can improve both profits and herd health? Visit us today at proearthanimalhealth.com. Be proactive with Cattle Active.
So to wrap us up, I've got a couple of questions for you.
Okay.
The first one is, what is your go-to beef resource? Book, website? What do you highly recommend someone that's watching this to utilize?
First of all, as a meat researcher, I would say that I go to scientific papers, right? This is my first go-to. If you want to learn more about it, you need to read a lot of scientific papers. But the podcast is also a great and an easy way, right, to find information. Once I'm here and we have great uh, guests and great researchers here, we can also easily find a lot of good information and listening, going to work, going home, etc.
Good, good. And so lastly, what in your opinion separates a highly successful beef person from someone that's less successful?
First of all, I would say teamwork.
Mm-hmm.
Because if you're able to work as a team, you empathize with the other, you can listen, you can contribute, you can have great ideas about something. Uh, and this is only possible if you're doing it in a group, in a team. You cannot have great ideas and discuss great things and innovate if you're doing it by yourself.
Right.
And the other thing is to ask great questions. Just ask if you're thinking that it's something it's bothering you. Ask, because sometimes people, I'm working with a lot of young researchers here in Brazil, and I know that they are great minds and they want to do great things with their lives, and sometimes they're just afraid to ask for help, for opinion, for
Yeah.
everything. So
No, that's a great answer. So team is everything, and being an N1, we get very little done. So that's a great answer. Well, thank you, Patricia, for jumping on the podcast. Really enjoyed the time, and really interesting research and what you're doing in Brazil, and looking forward to seeing what your group down there is going to come up with next.
thank you so much for having me.